What can 3D printing make, as far as you can imagine? Car parts, metal parts, even the human heart. But these are smaller items. Infrastructure fanatics have taken 3D printing to a new level, manufacturing the world's first in situ 3D printed double-story building. Let countless netizens call it incredible. A double office building with a height of 7.2 meters is seen on November 17, 2019. Complete the main structure printing in the construction base of the Second Bureau of China Construction Engineering Co., Limited. It is the first time that a building this tall has been printed in the world. Compared to traditional 3D printing, its in situ 3D printing construction technology has three major technological breakthroughs in the world's leading. First, in situ printing, this is the main body of the field directly printed into shape. No secondary assembly is required. Second, the contour process is adopted. It is cold in North China and the houses are not warm. The 3D printed wall is hollow. Warm fillers can be added inside. Third, it is the first time to apply this technology to the double-story building, which is more difficult in structure. The printing of the double-story office area of about 230 square meters. Intelligent control by computer, automatic operation by mechanization. It can print 24 hours around the clock. It took only 60 hours from start to finish. In addition to being fast, the building saves over 60% of its materials. Service life up to 50 years. 3D in situ printing is another major breakthrough innovation in China's technology and manufacturing. The basic principle of 3D printed buildings is the same as that of traditional printers. Have a printer, nozzle, ink and paper. The metal frame outside the building can be seen as the body of a printer. The printer head of the shotcrete is regarded as the nozzle of a normal printer. But the ink is concrete. Before the construction, the constructors embedded steel cage in the ground. These bars are equivalent to printing paper. During the printing process, the wall is continuously raised. The reinforcement will also grow along with the walls, making the whole building stable. The printer spray of concrete would be 5 centimeters in width, round and round. 2.5 centimeters thick print material. After layer upon layer to become the wall. And concrete pouring to be completed at one time, cannot be interrupted. There is another problem with printing. If the underlying concrete sets slowly, it does not form enough hardness. It is unable to support the weight of the upper material, leading to deformation or even collapse of the wall. If it sets too fast, it will fail to bond with the top layer of concrete. So the 3D printed concrete has a special mix. The admixture is added to the concrete mortar by adjusting the material viscosity and setting time. Eventually, concrete was developed specifically for 3D printing. Its strength can reach C40 C60, which fully meets the building strength requirements. In fact, 3D printed buildings did not originate from 3D printing. It started with building robots. Early as the 1970s, labor costs were rising. Engineers began to study robots to replace workers for external wall installation, cement pouring and other work. Later developed countries have developed a concrete spraying robot, concrete pavement finishing robot, steel beam fire layer spraying robot and so on. They greatly reduce labor costs and improve work efficiency. By the 21st century, 3D printing technology has gradually matured. The architects began to think, rather than using these various, fragmented construction robots, why not just make a complete, 3D printed building? So they designed 3D printed buildings. Traditional single-story house printing has become very common abroad. This is the world's first printing of a double-story building in China. Other countries have experimented with double-story printing. But consider the second floor for things and live people. At this time, the problem of 3D printing is highlighted. So the architects settled for second best. Add vaults to the building, reduce spans, add support, etc. A 200 square 2-story printing building. The interior supports more than twice as many columns as traditional buildings. The resulting 2-story house is not only economically inefficient, and seriously affect the use of housing space, so the final nothing. In terms of 3D printing of buildings, China has always been ahead of its time. Some say China is the only country that has really mastered 3D printed architecture. That's an exaggeration, but so far China is really the only country that can produce 3D printed buildings that are habitable. As early as 2015, China has built villas through 3D printing technology. But that would still be piecewise printing the parts in advance in the factory, then send it to the site for installation. A 1,000 square meter printed villa costs only 1 million yuan. An average square meter costs only 1,000 yuan. At present, this single-layer building has been sold abroad. Egypt alone ordered 20,000 units. With the development of multi-layer printing building in China, in the future, such a building will surely fill our streets. Create a city of science fiction, the green city for mankind. Comment down, how do you think about 3D printing building?